Now to solve things algebraically, and not just graphically, we're going to use some of the skills that we had talked about last year. For example, we're going to use some substitution. Of course, we're going to do some verification on here. So if we want to solve this one by substitution, if y equals negative 2x squared plus 10 and x subtract 2y equals negative 15, what we are allowed to do is wherever we see y, we can plug negative 2x squared plus 10. So we'd have, instead of having x subtract 2y, we can literally plug this entire negative 2x squared plus 10 into the bottom equation. So x subtracting 2, negative 2x squared plus 10, and our bracket equals negative 15. So x adding 4x squared subtracting 20 equals negative 15. I'm going to go a little bit into some quick math. I'm going to add the 15 and rearrange things in our entire next step. 4x squared plus x subtract 5 equals 0. Now, I'm going to go quick way, but of course, I'll kind of do the side note. Actually, yeah, I'll do the quick factoring. So I know the factors of 4 are either 1 and 4 or 2 and 2. The factors of 5 are only 1 and 5. If we need to find a sum to 1, there's no way that I can do anything with this 2 and 2 to give me to 1. But there is absolutely a way for me to get to a positive 1 using this stuff. If I have a 4 multiplied by a negative 1 and a 1 multiplied by a 5, I'm going to get to that 1 and still have a negative 5. But when we put that into this factorization, 4x would have to be multiplied. We'd have to have the 4x and x. We'd have to have a positive 5 there and a negative 1 there. 4x times x is 4x squared. 4x multiplied by negative 1 is negative 4x. 5x times x is positive 5, so negative 4x and positive 5 gives us 1. 5 and negative 1 gives me negative 5. Perfect. Of course, we're going to go into the long way because it doesn't hurt to just do a little review. Complex factoring, because of that 4. We can't just go product and sum. We have to actually do some extra work. So a product of negative 20 and a sum of positive 1. Obviously, our numbers would have to be a positive 5 and a negative 4. So this 4x squared plus x minus 5 would factor into a 4x squared. I'm going to actually put my negative 4 right there. Negative 4x plus 5x subtract 5 equals 0. Split her down the middle. Factor 4x. X subtracting 1 plus 5. X subtract 1. I guess technically don't even need that, equals 0. But x subtract 1 and 4x plus 5. Obviously, the order doesn't really matter because when we're solving it, in order to solve for the x here, we have to subtract the 5 and then divide by 4. So a negative 5/4. On this one, it would just be adding the 1 and we're set. So that's solving for our x. when we solved for it graphically, we needed to know an actual coordinate. We needed to know an x and y. So to find out what the y value is, we just have to plug it into our equation. Now, it works out really nicely into our first one because it already has things solved for y. So if x equals -5/4, I'm just going to put another line there. Our y value would equal -2 multiplied by a -5/4 squared plus 10 So y would equal, let's see, -5/4 squared would be a 25/16. 2 and 16 are going to reduce. And then I'm going to get to this common denominator right away here. I know this would just be a -25/8, adding an 80/8. So -25/8, well, -25. Adding the 80 should be a 55. Yep. So the y would be 55/8. So this coordinate would be a -5/4, 55/8. Of course, the 1 is going to be a lot easier to do. So when x equals 1, solving for the y value, -2, put the 1 in. It should be black there. Add 10. 1 squared is 1 times by -2 is -2. Add 10 is 8. So the coordinates here would be 1, 8. Now just to verify, so this just solved for our coordinates. Essentially, this is what our answer is. That's where this parabola and this line would be crossing. To verify, we're going to use each of these points. So let's verify the easy one first. 1, 8. Well, we're going to put this 1 and 8 into the other equation. 1 subtracting 2 times 8 equals -15. So 1 subtracting 16 equals -15. Absolutely, -15 equals -15. Now to verify the other point, the -5/4, 55/8. There, x is -5/4. Subtracting 2 multiplied by a 55/8 equals -15. I'm going to save myself a little bit of work. That'll be a 1 and a 4. So since our denominators are already 4, -5 subtracting 55 would be a -60/4. And -60/4 is -15. So we solve for our x's, we solve for what the y's would be. Those would be the coordinates. We verified by plugging them into the other equation. Yes, algebraically, things can take a little bit more time. But in personal perspective, it actually makes it a little bit more satisfying just doing all that math. Yes, I know I'm weird. All right, do another one. Solve this one by substitution. So to solve it by substitution, y equals this, y equals this. So obviously we're looking at two parabolas here. They're two x squareds. This one's a positive parabola, this one's a negative parabola. So it could So they could potentially cross in 3 different ways. Either they would have 0 crossings, they would just touch, or they would cross in 2 different points. Now, since they both equal y, it means that this entire equation, so instead of writing y in this equation, I'm just going to write 2x squared minus 7x plus 3. That's all that it takes for this substitution. Now to get one side equals 0, I'd be adding my x squared over, I'd be subtracting my 6x, I'd be adding my 7, it would equal 0, and I'm going to do this quick factoring. Factors of 3 are 3 and 1, so that's going to make it really easy. I don't have to do anything further. Now for 10, my factors are either 1 and 10, but 1 and 10 would never give me 13. Actually, they would. Negative 10, negative 1. Yep. Actually, they would. They would work. I was thinking that I was gonna go down to 2 and 5, but no, 2 and 5 wouldn't work. So yeah, I'll actually go through that exercise. So don't write this next one. This one's the wrong one. So 1 and 10 are going to work. But if I used 5 and 2, so if I went 5 and 2 here, in order to get to negative 13, I'd have to have this as a negative 5 and this as a positive 2. So I guess 3 times, obviously 3 times x would give me the 3x squared. 3x times negative 5 would give me negative 15. 2 times x would be 2. So negative 15 and positive 2 would give me my negative 13. But a positive 2 and a negative 5 would never give me positive 10. So 2 and 5 would never work here. But if I change this, made this a negative 10, I made this a negative 1, 3x times negative 1 is negative 3x, negative 10, and x is negative 10x. So negative 3 and negative 10 gives us negative 13, and negative 10 and negative 1 gives me positive 10. So we're all set there. Solving this, add the 10, divide by 3, that'd be 10 thirds. Add the 1, we're at 1. Now to find out the coordinates, it doesn't really matter which equation we use. It might actually be a little bit nicer plugging into the bottom one. So if x equals 10 thirds, y is a negative 10 thirds squared, add 6 times 10 thirds, subtracting 7. So y would be a negative 100 ninths, adding, save myself a little bit of extra work here, this would just become 2. Add 20, subtract 17. So y would be negative 100 over 9. I'm just going to combine these two because they don't have any fractions. Then I'm going to get a common denominator. And 13 by 9 is 117. So negative 100 add 117 would put us at 17 ninths. So our coordinates here, 10 thirds and 17 ninths. So let's solve for the other one. When x equals 1, negative 1 squared adds 6 times 1, subtracting 7. So 1 squared is 1, negative 1, add 6 would put us at 5, subtracting 7, negative 2. So this coordinate would be 1, negative 2. So let's go to the verify. let's do the hard one first. Oh, sorry, x equals, we're actually doing the entire verifying the point. So 17/9. Sorry, just so you can see, I'm verifying this point. My y value is 17/9. The x is 10/3. 2 by 10/3 squared, subtracting 7 by 10/3, adding 3. So does 17/9 equal, let's see, 2 by 100/9. I'm just going to quickly do that as 200/9. Subtracting 70/3, adding 3. Go pretty fast into those common denominators. I have to multiply this one by 3/3, and this one would have to be a 9/9. So I will show this bit of work. 200/9, subtracting 210/9, adding 27/9. So 200 subtracting 210 is -10. Adding 27 is absolutely 17/9. So this point works. So this was verifying the coordinate 10/3, 17/9. Now let's verify the point 1, -2. So -2 would equal 2 times 1 squared, subtracting 7 times 1, add 3. 1 squared is 1 times 2 is 2, subtracting 7, adding 3. 2 subtracting 7 is -5, add 3 is -2. So both of those points work. Alrighty, let's do some more examples. Now we're going to do this one actually by elimination, or I think these next two. Yeah, we're going to do these next two by elimination, which is another one of those skills. In order for us to do some elimination, what we want to do is we want to set things up where all of our same kind of terms are completely one over the other. Now, this one has a big 4x squared, so I'm actually going to rearrange this so this entire bottom equation is actually on top. Sorry, not subtract 7, should be subtract 9. And I'm going to rearrange this top equation, put it underneath, but I'm going to line up my same kind of variables. And in order to eliminate, we're going to either add or subtract something so that we completely get rid of it. For elimination in this case, we really want to eliminate the y. Almost always we're going to want to eliminate our y. So when we subtract everything, and we are going to subtract everything, 4x squared subtracting essentially 0x squareds is 4x squared. Negative x subtracting 3x is a -4x. Y subtracting y is 0, so it's gone. A -9 subtracting -9, subtracting a negative is like adding a positive, so -9 add 9 is 0. So here's our entire equation. 4x squared minus 4x equals 0. So there's a whole bunch of, basically there's a whole bunch of reasons for all the examples that I have in this unit. And the first one was to remind us how to do complex factoring. Actually, both equations. This one is reminding us that there is one step before we can even do any product and sum. And it's our first step to factoring. Each and every single time, factor out our GCF. So we can factor out a GCF of 4x and be left with an x subtract 1. For x equals 0, when x equals 0, x minus 1 equals 0, add 1. So let's solve for some coordinates. When x equals 0, now out of here, basically the easiest one to do here is because we don't have to do anything really special here. I would probably plug into the top one. You could absolutely plug in the bottom one. It's going to give us the exact same answer no matter what, especially since we are going to verify it. 3 times 0 plus y equals negative 9. Well, 3 times 0 is 0. So there's nothing really to get rid of. Y equals negative 9. So this coordinate is 0, negative 9. I'm just going to go right away and just say that we're going to have to verify this point 0, negative 9. But let's also do x equals 1. So 3 times 1, add y equals negative 9. 3 times 1 is 3. We subtract the 3. Y equals negative 12. So 1, negative 12 is the other one that we're going to verify. Oh, that should definitely read negative 12, not negative 2. 1, negative 12. Apparently I don't like writing the tens. Anyways, to verify it, we just plug our x's and y's in. So 4 times by 0 squared, subtracting 0 plus a negative 9 equals negative 9. 0 squared is 0 times 0 is 0. Subtracting 0 is 0. Add negative 9 is negative 9. So that one works. That point is absolutely where this line and this parabola would be crossing. Let's verify this one. 4 times 1 squared, subtracting 1, adding a negative 12. Does that equal negative 9? 1 squared is 4. Subtracting 1, adding negative 12, which does mean subtracting 12. 4 subtracting 1 is 3. 3 subtracting 12 is negative 9. So that one works, which means that point also works. And this one was solved by eliminating. One example isn't good enough. I want to do another one. So in here, it's going to be a little bit harder. See, I still want to eliminate my y's. Realizing that time is going out a little bit. So I want to line up my y's. So I'm going to rewrite this bottom equation so it says y equals negative x minus 3, just by subtracting that x over. Now that I have that, my top equation is y equals 1/3 x squared minus 3. The other equation, actually, sorry, I'm going to do a little bit of a rearrangement here. Minus 3 over there. The bottom equation now is read as y equals negative x minus 3. So let's eliminate stuff. Let's subtract it. Y subtracting y is 0. Actually, I'm going to go to my blue. 1/3 x squared subtracting 0 x squareds is a 1/3 x squared. 0 x's subtracting a negative x is add an x. Negative 3 subtracting negative 3 is 0. So we have 1/3 x squared plus x. Now there's two ways of working with this. Sometimes people don't like working with the fraction, and this could have actually been a step that we could have done up here, is we could have done some more special work up in here. Actually, I might as well show that. Instead of doing a verify on this one, I'm going to show you another way of doing this entire question. So to finish this one off, I'm actually going to, just like before, I'm going to actually take out that GCF of x. Sorry, not an x squared, it should just be an x. So where does x equal 0? Well, x equals 0 at 0. But in order to solve this one, I'm going to do this one as a little bit of a side note. 1/3 x plus 1 equals 0. Well, we have to subtract the 1. 1/3 x equals -1. And then we need to try and get rid of this. So either we divide by a 1/3, or another way of getting rid of this 1/3 is multiplying both sides by 3. Because that would eliminate 3. Because no matter what, if we divided this by 1/3, dividing 1 by a 1/3, in order to divide fractions, we flip and multiply. So instead of dividing by 1/3, we would still be multiplying by 3. So this one, x would be -3 in no matter what situation. So let's quickly just solve for what our y would be. Really, the bottom equation would probably be the fastest, since we actually do have it solved for. So to solve for what our y is, -0, subtract 3, y equals -3. So our coordinates would be 0, sorry, that should be -3. 0, -3. If we use -3 into this equation, a negative of -3, subtracting 3. So negative of -3 is 3, subtracting 3 is 0. Okay, this is kind of a cool one. Our x is -3 or y is 0. So our coordinates are of where this parabola and this line would be crossing are actually 0, -3, and -3, 0. Okay, that's kind of cool. Yes, I know, I'm a nerd. So instead of doing the verifying, which should work if we plug into here, I'm going to show you another way that this can be worked through. It actually comes to dealing with this fraction. Just like last year, we didn't really work with a lot of fractions. Well, actually, we did, but we got rid of our fractions because we were smart about it. We were smart about it because we wanted to get rid of that fraction. We multiplied everything, every single term, by a common denominator. A common denominator between 1, 3, and 1 is 3. So we have 3y equaling x squared minus 9. Now, in order to get rid of our y's, this bottom equation still has, so we will still kind of carry over this little bit of work down. Actually, bring over here. In order for us to eliminate anything, we're going to still need to get rid of our y's. And since we multiplied this entire top equation by 3 to get rid of the fractions, we have a 3y. Well, in order to get rid of a 3y, we need to somehow, in some way, get this entire equation also have 3y's. So we're actually going to multiply all of these by 3 as well. So now, when we bring this down, let's see. I am actually just going to put this -9 over here. And I'm going to put my -3x at the end, just so I can have this stuff kind of lined up nicely. 3y subtracting 3y is still 0. X squared minus 0ing x squared is x squared. -9 subtracting -9 is 0. And 0 x's subtracting -3x's is a +3x. So when we quickly solve this, we can factor out our x plus 3, x equals 0, and x equals -3. So that stuff still works out the exact same way as before. Now, of course, everything is not finished without some word problems. So let's create, and we're going to solve these word problems. Now I will for sure do my best to just keep things organized as it is. So we have two, yeah, some quick questions there. We're going to create and solve these systems. So 2 times the first number subtract 5 is equal to the second number. The sum of the second number and the square of the first number is 115. So literally, if we just classify our numbers as x and y, we can do a lot of damage or a lot of quick work here. 2 times the first number subtract 5 is equal to the second number. So that first entire equation is saying that if I take 2 times my x, I subtract 5, it's going to be equal to the second number of y. The sum of the second number and the square of the first number is 115. So sum means add, so if I just take my second number, which is y, and the square of the first number, so the square of x is x squared, it is a key word for equals 115. So we can do a lot of work here, do it really quickly, and we have just created our 2 equations that we're working with. Now I'm going to solve this one by substitution, and I will try and solve that next one by elimination. 2x minus 5 is y, so instead of writing y, I'm just going to write 2x minus 5. So 2x minus 5 plus x squared equals 115. So x squared plus 2x. I'm actually going to save myself a little bit of work. I'm going to subtract my 115 right away. Two numbers. So since our leading coefficient, our number in front of our x squared, our a value is 1, we can do this as a quick product sum. Remember when I said that this unit was going to be a whole bunch of review of stuff that we've done before? All of this is exactly what I was talking about. Product of negative 120 and a sum of 12, or sorry, sum of 2 would be 12 and 10. So x plus 12 and x subtract 10. So x equals negative 12 and x equals 10. So that's what these two, or that's what the first number is. We need to still solve for what y is. So if x equals negative 12, what does y equal? 2 times negative 12 subtracting 5 equals y. Negative 24 subtracting 5 is negative 29. So this would be negative 12, negative 29. If x equals 10, 2 times 10 subtracting 5 equals y. 20 subtract 5 is 15. So this would be 10, 15. To do it as a quick verify, negative 29 plus negative 12 squared, does that equal 115? Negative 29, add 144. Negative 29, add 144 is absolutely 115. That's good. Now if I do the same thing over here, sorry, not negative, 15 plus 10 squared. Does that equal 115? Well, 10 squared is 100 plus 15 absolutely equals 115. So we have two different ways that this word problem actually produces the same answer, or like the same, produces a solution. There didn't need to be any kind of full relationship between our x's and y's, or for our first number and second number. All right, we did this one by substitution. We'll do the other one by elimination. The square of the first number, subtract the second number, is equal to 5. The first number is equal to the second number, subtract 7. So once again, let's just say that our first number is x and our second number is y. The square of the first number, subtract the second number, is equal to 5. So the square of the first number is x squared. We subtract the second number, that's subtracting y, it's equal to 5. The first number is equal to the second number, subtract 7. So x would equal y, subtract 7. So in order to put this into a nice form to actually eliminate, what we want to do is we would actually want to subtract the y and add the 7. As well as we're going to actually add the 5, or sorry, subtract the 5 over as well. So the first equation becomes x squared. I'm going to leave a little bit of space here. Subtract y, subtract 5 equals 0. And our bottom equation is x, subtract y, add 7 equals 0. So by setting this up so that we have the same kind of things over each other, we can fully eliminate a whole bunch of our stuff. X squared subtracting 0 x squareds is x squared. 0 x's subtracting x is a negative x. Negative y subtracting negative y is 0 y. Again, I set this up so that I can eliminate my y's, because really, for elimination, we want to eliminate our y's. Negative 5 subtracting 7 would be a negative 12. Quick factoring, this is x subtract 4, x add 3. So x would equal 4 and negative 3. It doesn't really matter. No, I did verify that one. Oh. Here, I'll plug in the first one, make my life easier on the second one. So x is 4, 4 squared subtracting y equals 5. That's 16, subtracting y equals 5. I subtract my 16 over. 5 subtracting 16 is negative 11. Divide by the negative 1. Y equals 11. So this would be 411. And if I do it similarly, negative 3 squared subtracting y equals 5. So that's 9 subtracting y equals 5. Subtract the 9 over, that's negative 4. Divide by the negative, and y equals 4. So this would be negative 3, 4. So to verify, x is 4, 11 subtract 7, absolutely 4 equals 4. If x is negative 3, 4 subtracting 7 is negative 3. So both of these work. Oh, that wasn't intentional. Alrighty, have some fun.